Welcome to the 8.6 notes video. We're picking up where we left off last class, talking about quadratic equations, but this time we're looking at graphing quadratic functions that might not be in vertex form yet. So in our last class, we looked at graphing based on transformations, and this time we're going to look at, well, how do we graph if it's not given in that form? So recall, there are two different forms of quadratic equations that we've seen so far. We have the standard form, which is ax squared plus bx plus c equals 0. So everything is set equal to 0. Or we also have vertex form, and this is the one that we looked at last class. A times the quantity of x minus h squared plus k equals 0. Where we have x being squared, we have something being added. This was our vertical motion. The h was our sideways motion. And the A was our stretch or compression, okay? So we can find the standard form from vertex form. If we're given the vertex form, going into standard form is pretty easy. We can just distribute, so that's foiling out that squared term and then combining like terms. But to find vertex form from standard form, we need to complete the square, okay? And by the end of today's lesson, there will be a shortcut that we can use. But the first method we're going to look at is by completing the square. So recall, that's what we were doing a couple of sections ago, of finding the value that we need in order to write something as a perfect square. Okay, and when we're looking at vertex form, we're able to find the vertex, which was the point h comma k. And we saw that last class. Okay. We also want to recall an intercept. So an intercept, when we're graphing, is where something crosses the x or the y axis. So whether it's a line or a parabola, our intercept is every point where the graph crosses these axes. So the definition of an intercept is where the graph of a function crosses the axes, and that's x or y. Okay, so we can have two different types of intercepts. So let's go ahead and look at example 1. In example 1, we're given a function. Notice this is not written in vertex form because I have an x that's not squared. So in order to write this from standard form into vertex form, we need to complete the square. So let's look at it as f of x equals x squared minus 4x minus 12. We want to bring over the constant. So we have f of x plus 12 equals x squared minus 4x. And then we do our side work. So we have negative 4 divided by 2 is negative 2. Raised to the second power is negative 2 squared, which is 4. And that's the number that gets added to both sides, plus 4 plus 4. So we have f of x plus 16 equals x squared minus 4x plus 4. And the whole idea behind adding the plus 4 is to write this as a perfect square. So we have f of x plus 16 equals, if we factor that, we get x minus 2 squared. Recognize that the minus 2 is the same value we got from the first step of completing the square. But then we want to subtract the 16 back over so that we have it in function notation. So we have, excuse me, f of x equals x minus 2 squared minus 16. Okay, so now we have this function in vertex form. This is now vertex form. So we can say this moved down 16, and the value that would make that 0 is a positive 2, so it goes to the right 2. Therefore, we have the vertex at the value of h, which would be 2, and k, which is negative 16. Whoops. 2 comma negative 16. Okay, so our vertex here is 2, negative 16, but our graph only goes down to 10, so let's scale by 2's. So that's 2, negative 2, negative 2, 2, 2, 4, 6, 8, and so on. So over 2, down 16. So that's 2, 4, 6, 8, 10, 12, 14, 16. So that there's the point 2, comma, negative 16, and that's our vertex. Okay, and then we can find points again by substituting into an XY table, but the question is asking for any intercepts. So remember, to find intercepts, to find where we intersect with our X and Y axis, we need to set X equal to 0 in order to find the Y intercepts, and we set Y equal to 0 to find the X intercepts. We did this particularly when we were doing linear equations. So if I take my equation here, f of x, and I set x equal to 0, then I'm finding f of 0, which is 0 minus 2 squared minus 16. 0 minus 2 is negative 2 squared minus 16. Negative 2 times negative 2 is a positive 4 minus 16, which is negative 12. So we get the point 0, negative 12 as our intersect. So 0, negative 12. 2, 4, 6, 8, 10, 12. There's our intercept. And then when y is 0, and remember y is the same as f of x. It's just two different names for the same thing. So this is the same as setting f of x equal to 0. So we have 0 equals x minus 2 squared minus 16. Add 16 to both sides. So we get 16 equals x minus 2 squared, square root property. So we get plus or minus 4 equals x minus 2. Well, this is actually two different equations. We get 4 equals x minus 2, and negative 4 equals x minus 2. Add 2 to both sides, so we get 6 equals x. Add 2 to both sides, negative 2 equals x. So we actually get that x equals negative 2 and 6. Two answers, just like we were seeing in the last few sections. And what that means is that we actually have 2 points here, negative 2 comma 0 and 6 comma 0. So negative 2, 0, 2, 4, 6, 0. And so we have our parabola that goes like this. So notice, instead of doing an XY table, which we still could do, since we were looking specifically for the intercepts, we set x equals 0 and y equals 0 to find those intercepts. Let's look at another example. On example 2, again, we're given a function, but it is in standard form. Standard form. And so in order to put it into into vertex form, to find the vertex and any intercepts, we can complete the square. So we're going to, again, start with rewriting the equation. And then completing the square, we want to subtract our constant. So we get f of x minus 1 equals 3x squared plus 3x. But this time we have a coefficient, so we need to divide everything by 3. So we have f of x minus 1 all over 3 equals x squared plus x. So my coefficient here is 1. 1 divided by 2 is a half. Raised to the second power, 1/2 squared is 1/4. So I'm adding 1/4 to both sides. Okay, on the right or on the left-hand side now, I have an addition of fractions, which means that we need a common denominator, or we can leave them as two separate terms. F of x minus 1 over 3 plus 1/4. So since I know I'm going to be isolating f of x later, we don't actually have to add these two. We can leave them separate. And then we'll take care of our right-hand side, which we want to factor into a perfect square. That is x plus 1/2 squared. Again, the 1/2 comes from our step of completing the square. If we were to FOIL this out, we should get x squared plus x plus 1/4. So the next step is going to be subtracting over the 1/4. So now we're in the step where we're ready to isolate f of x. So minus 1/4 f of x minus 1 over 3 equals the quantity of x plus 1/2 squared minus 1/4. Multiply everything times 3 every term. So we have f of x minus 1 equals 3 times the quantity of x plus 1/2 squared minus 3/4. And then plus 1 plus 1. So we'll have f of x equals 3 times the quantity of x plus 1/2 squared. Now, in order to add the negative 3/4 plus 1, we need to rewrite 1 as 4 over 4. So we have a common denominator, and we can add across the numerators. So we get plus 1/4. So now we want to find the vertex, which is h comma k. So we need to know, what are our values for h and k? Well, h is the value that would make this 0. So x would have to equal negative 1/2 to make that 0. So the vertex is negative 1/2, comma, and k is this value that's added on here. So k is 1/4. Negative 1/2, comma, 1/4. Okay, and then we also want to find any intercepts. So remember, that's in the step above where we set x equal to 0 and y equal to 0. So when we set x equal to 0, we're finding f of 0, 3 times 0 plus 1/2 squared plus 1/4, which is 3 times 1/2 squared plus 1/4, which is 3 times 1/4 plus 1/4. Oops, extra parentheses. So that's 3/4 plus 1/4, because we can look at it as a 3 over 1, which is 4/4 or 1. So we get the point 0, comma 1. And then we set y equal to 0. And when we set y equal to 0, that's the same as setting f of x equal to 0. So we get 0 equals 3 times x plus 1/2 squared plus 1/4. Okay, and we can solve this again by using the square root property. So subtract 1/4 over, negative 1/4 equals 3 times x plus 1/2 squared. Divide by 3, so that's divided by 3, divided by 3. Negative 1/4 divided by 3, multiply by the reciprocal, negative 1/4 times 1/3. So that's negative 1/12 equals x plus 1/2 squared. Square root property. Notice this is going to be a complex number. Square root of negative 1, non-real number. So remember, if we have a non-real solution, that means no x-intercepts. So that's nice. We don't have to keep solving from here, because as soon as we recognize that it's not going to be a real number and we won't have any intercepts, then we won't have any other points to find for our solution. So when we go to the graphing part, just like above, we want to change our scaling, because I don't want to graph the point at 1/4. So instead of scaling by ones, maybe we scale by quarters. So 1, 2, 3, 4, there's 1. 1, 2, 3, 4, that's 2. And then the same on the y-axis, 1, 2, 3, 4, that's 1. 1, 2, 3, 4, that's 2. So to graph the point negative 1/2, comma 1/4, we go negative 1/4, negative 1/2, down, or negative 1/4, negative 1/2, and then up to 1/4. So there's my vertex. To graph the point 0, 1, 0x, 1y. And then remember the symmetry of a parabola. Since this goes over 2 and up 3 from the vertex, we can go over 2 the opposite way and up 3, and we have our other point. That one is by symmetry. And so we have this as our parabola. And notice it never crosses the x-axis, which is why we ended up with non-real solutions when we were solving for our x-intercepts. All right, let's take a look at the next page. All right, so at the next page, we're looking at example 3. And again, we have a function given in standard form. We want to find the vertex and any intercepts. So the easiest way to find the vertex that we know so far is to complete the square. And so we take the function in standard form, f of x equals negative x squared minus 2x plus 3, subtract 3, f of x minus 3 equals negative x squared minus 2x, divide by negative 1. So now we have negative f of x plus 3 equals x squared plus 2x, because dividing by negative 1 changes all of the symbols. We take our middle coefficient, 2 divided by 2 is 1, raised to the second power, 1 squared is 1, plus 1, plus 1. So we have negative f of x plus 4 equals x squared plus 2x plus 1. The left-hand side is already simplified, so we can just copy that, equals, and then the right side we want to factor, x plus 1 squared. And now we have it in squared form, so we want to solve for f of x. Minus 4, negative f of x equals x plus 1 squared minus 4, divide by negative 1. So f of x equals negative the quantity of x plus 1 squared plus 4. To find the vertex, we're looking for h and k. H is the value that would make this 0, so h is negative 1. And k is the value that's added on at the end, so k is 4. So we have negative 1 comma 4. And then to find the intercepts, we set x equals 0. When x is 0, f of 0 equals negative 0 plus 1 squared plus 4, which is negative 1 squared plus 4, giving us negative 1 plus 4 equals 3. And when y equals 0, f of x is 0. So we have 0 equals negative quantity of x plus 1 squared plus 4. Now, we can subtract the 4, but notice this is negative. So instead of subtracting 4, I'm going to subtract the quantity of x plus 1 squared, which will make it positive. So now we have x plus 1 squared equals 4, square root property. X plus 1 equals plus or minus 2. This gives us two equations. X plus 1 is 2, or x plus 1 is negative 2. Subtract 1, x is 1. Subtract 1, x is negative 3. So we have 2 points here, 1 comma 0 and negative 3 comma 0. Now, these points are all nice to graph on a regularly scaled axis, so we don't have to change the scaling here. Our vertex is at negative 1, 4. Our y-intercept is at 0, 3. And our x-intercepts are 1, 0 and negative 3, 0. Now notice by symmetry, I could also put a point here. So here is our parabola. As expected, opening downward because our leading coefficient is negative. And the vertex, again, is found by those transformations, 1 unit to the left and 4 units up. Okay? Another thing that is kind of like a shortcut, when given the standard form, finding f of 0 is the same from vertex form or standard form. So if I wanted to find f of 0 in standard form, negative 0 squared minus 2 times 0 plus 3, it's always just the constant at the end, kind of like a y-intercept. Okay, so another way to find the y-intercept is to use the standard form and look at just the constant that's on the end of your equation. It's the same as finding f of 0 in vertex form, or standard form should always be the same value. Okay, so now that we've seen a few examples of how to graph standard form of these quadratic equations, let's go back and look at other ways to solve for these intercepts. So there's a couple ways. Notice when we're solving when f of x is 0, that's the same as solving a quadratic equation. So we could also have set our original standard form f of x equal to 0. So for the intercepts, we don't need our function in vertex form. That's mostly, as it says in the name, to solve for the vertex. So another way to solve for our intercepts, even from standard form, is to use the quadratic formula. So let's recall the quadratic formula. And remember, there's that catchy little tune that helps us remember this. So the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is one of the formulas that you absolutely need to remember by heart, okay? The parts of the quadratic formula that we've investigated even further, underneath the square root, the b squared minus 4ac is called the discriminant, and that's what tells us how many and of what type our solutions are. And then the parts that are not under the square root, the negative b over 2a, is going to be the second part that we're investigating right now. And this part, the negative b over 2a, gives us our vertex formula. So that's what we're going to look at right now. When we're looking at the vertex formula, the graph of f of x in standard form, notice this is standard form, as long as a is not 0, so we're talking about it has to be a quadratic equation, is a parabola with vertex, and h, remember this is also hk, so h, the x coordinate of our vertex, is always going to be equal to negative b over 2a. So this is that shortcut that I mentioned at the beginning of the video. The shortcut, instead of having to complete the square in order to find the vertex, is to use the vertex formula. Now, whenever I have an x value, in order to find the y value, I substitute it back into the formula. So if I know that my x value is 2, in order to find the y value, I would substitute all of those x's with 2. So if I know that h is the negative b over 2a, then to find k, which is the y value, I substitute that back into my function. So let's see if we can use this in example 4. For example 4, we have an equation in standard form, and in order to find the vertex, we want to use the vertex formula. So the first thing I'm going to do is label a is 1, b is negative 4, and c is negative 12. So I have my values for a, b, and c. And then to find the vertex, we use just that first part of the quadratic equation, the negative b over 2a, and we're going to substitute in our values. So negative b, which is negative 4, divided by 2 times a. And simplifying, if I have negative of a negative, it becomes positive. So this is 4 over 2, which is 2. So I know that the x value of my coordinate is 2. In order to find the y value, I take 2 and I substitute it in for all of the x's. So what that means is that I'm finding f of 2. So we have 2 squared minus 4 times 2 minus 12. 2 squared is 4. Minus 4 times 2 is 8. Minus 12. 4 minus 8 is negative 4 minus 12 is negative 16. So we have the vertex, which is h comma k, which is 2 comma negative 16. So now that we have this vertex, we can actually use it backwards in order to find the vertex form. So instead of going from standard form and using completing the square to find the vertex, we're going to try doing it the other way around, where we have the standard form, we use the vertex formula to find the vertex, and then we're going to use that in order to find the vertex form. So remember, our vertex form is f of x equals a times the quantity of x minus h squared plus k. And we have our values for a, h, and k. So that means I can find the formula to be 1 times x minus 2 squared plus negative 16, which we can then simplify to f of x equals x minus 2 squared minus 16. That is vertex form without having to complete the square. Now, sometimes it's easier to complete the square than to find the vertex and substitute it back in, but we have the option now of doing either. Okay, so now we want to use all of the information we have from both example 4 and example 5, the standard form, our values of a, b, and c, the vertex and the vertex form, to see if we can find the solutions, which are also called the x-intercepts, and we also can call them the zeros. Okay, so how do we solve for that? Well, if we have the vertex form, the square root property is usually easier than using a, b, and c for the quadratic formula. And that's one of the main purposes of being able to find vertex form after we have the vertex. So let's use the vertex form to solve for x. The x-intercepts means y equals 0, right? On the x-axis, all of these points have a y value of 0. So we have 0 equals x minus 2 squared minus 16. Add 16 to both sides. 16 equals the quantity of x minus 2 squared. Square root property with the plus or minus. So we have plus or minus 4 equals x minus 2. This is actually two different equations. We have 4 equals x minus 2 and negative 4 equals x minus 2 plus 2. So x equals 6 plus 2, x equals negative 2. And so the solutions, which are also called the x-intercepts, which are also called the zeros, are the points 6, 0, and negative 2, 0. And those 2 points are the solutions to the vertex form and the standard form, which represent the same function. Let's go ahead and take a look at the try this. What I want you to do with the try this is follow along from example 4 and 5. Okay, find the vertex. You have a choice now. You can use the vertex formula or you can use completing the square. And then I want you to find the solutions. Now remember, the solutions is the same as saying the x-intercepts, and we can also say that they're the zeros. They mean the same thing. Okay, our next section, our last thing that we're going to look at today, is finding the maximum or the minimum. So when we were looking at linear functions, there was no maximum or minimum because a line is always increasing or always decreasing, and so there's no top or bottom point. However, when we're looking at parabolas, we can have an upward-facing parabola, which does have a bottom point, or we can have a downward-facing parabola, which does have a top point. And therefore, we'll have a maximum and minimum for any quadratic function. The minimum, like the smallest, is going to be the bottom point. The maximum is the biggest, is going to be the top point. And so, okay, so either way, when we're looking at a parabola, there will always be a maximum or a minimum. And either way, the maximum or minimum will always be the vertex, right? It'll always be at the vertex. So the smallest value on this function is this value right here. The highest value of this function is this value here. Notice it's always a y value that will be the highest or the lowest. And so the maximum or minimum value of a quadratic equation is always equal to k, right? Because our vertex is always h comma k, and so the y value at that point will always be k. So the extreme value of any quadratic function will always be at the vertex, h comma k. But the extrema, so the value of that point, if I'm talking about the maximum or the minimum, the most or the least, will be the k value, the y value of the vertex. Okay, so I'd like you to think about this concept check. Without making any calculations, tell whether f of x will have a maximum or a minimum value and explain why. And I'll have you type that in on Edpuzzle. And then we'll do the last example together. Okay, so on example 6, we're looking to find the maximum height of a rock. So a rock is thrown upward from the ground. Its height in feet above the ground after t seconds is given by this function here. Find the maximum height of the rock and the number of seconds it took for the rock to reach its maximum height. So the first thing we want to do is kind of visualize what's happening. If we are on the ground, here's me on the ground, and I have a rock, and I'm throwing it. Maybe I just want to see how high I can throw the rock. Well, when I throw it, it makes an arch like this, okay? So the arch represents the height of the rock. And this equation right here is used to represent that. Notice this is an upside down parabola, okay? So we want to find the height of the rock, and we want to know when will it be at its highest point. Well, when will it be at its highest point is the vertex. So we want to find the vertex. Well, in order to find the vertex, we take h of t equals negative 16t squared plus 20t, okay? And this is not the vertex h, this is height. So h of t here represents not h from the vertex, but h for height, okay? So make sure you keep those two h's separate. So to find the vertex h, we use the vertex formula, negative b over 2a. A is negative 16, b is 20. So we have negative 20 divided by 2 times negative 16, which gives us negative 20 divided by negative 32, which we can then simplify, and negative divided by negative becomes positive. And so we are at 5/8. Okay, now h is our x coordinate, right? This is the x coordinate. So that gets substituted in. Well, what value gets substituted into this function, i.e., what does t stand for? T is for seconds. T is for time. So this value, 5/8, is a unit of time. 5/8 seconds. In order to find the other half of our coordinate, we need k. K is the x coordinate. So we substitute h into the function. H of 5/8, which gives us negative 16 times 5/8 squared plus 20 times 5/8. You can use your calculator to simplify that if you'd like, and you should end up with 25/4. Now k, representing the y value, right? This is the y coordinate, represents the height, right? H here represents height. So this is in feet, okay? If we want to look at this as an estimate, if I tell you someone is 25/4 feet tall, it doesn't mean as much as if I say that is actually equal to 6.25 feet. So in fraction form and in decimal form. So let's see if we can answer the question now. Find the maximum height of the rock. Well, the maximum height of the rock, the max height of the rock is 6.25 feet. And The number of seconds it took for the rock to reach its maximum height. Well, the number of seconds, or the time, was our x value, and so that is, it took 5/8 seconds to reach this height. Okay, so really this whole question was asking for the vertex and the interpretation of what that vertex means. Okay, again, we'll have a chance to talk about if you have any questions about this in class, but what I'd like you to do is write your summary in Edpuzzle, and if you do have any questions that you want me to answer before class, make sure to email me. If you have questions that you want me to answer in class, make sure to submit the form that's on the Blackboard topics page.